By request, here's some patching ideas for stages. Right now, we've got marbles sequencing plats going into ripples. And let's hear what that sounds like. Now I've also got the clock from marbles clocking the sequencer of stages. We're going to patch this into the filter modulation CV. So I have these set to orange, and then I have the first three segments set to green, cycling as LFOs. So now we're going to patch this as a sequential switch. Next, we're going to use stages as a sample and hold and Bitcrusher, using this last stage, which is set to orange. So we're using the same sequence. And we're going to patch the output of this stage into filter modulation again. And we're going to sample noise from the disting, which sounds like this. Just some regular white noise that you can get anywhere. We're going to plug that into the time and level. And that's pretty chaotic. So we're going to want to clock that with this Depfer LFO square wave using it as a clock. Now we're going to get a little weirder. We're going to use this as a Bitcrusher by unpatching everything except for the clock. We're going to patch the filter output into the time and level in, and then the stage output into our audio path. Now, because it's an LFO, we're not going to hear much. If we switch it into audio speed, now this works similar to sampling digital audio. You're basically changing the sample rate. Next, we're going to use the new firmware, which allows you to have a quantized volt per octave sequencer. Go download the Mutable forms if you haven't already. But the way it works is you make a green stage followed by however many orange stages as you want. Let's take a listen. And there's a couple different modes, forwards, backwards, ping pong, random. But when you turn it all the way to the end, then the CV slider addresses each step of the sequence. Now, the time and level jack will do the same thing. So say we make this an LFO. Now, getting a little more sophisticated than LFO, we're going to use the first stage as an envelope to strum the chord. So we'll take this out of LFO mode, and we're going to mult this. So now this is acting as a decay envelope. We're going to patch this into the time and level jack again. Next, we're going to explore a sequence that modulates its own speed. So we have channel 1 as a square wave LFO set up as a clock, clocking the sequence that's patched to filter cutoff. Now, let's have channel 2, also an LFO, modulate the speed of that clock. It's cool, but it's a little predictable. So we're going to patch the output of that LFO into the input of a VCA. And then we're going to patch the output of the sequencer into the level control of the VCA. And then we're going to patch the output of the VCA into the time and level jack. Now, the output of this is a little more random because the level of the sequence is controlling how much the LFO modulates the speed. So instead of a predictable up and down cycle, you get an interrupted one depending on where in the sequence it is. Finally, we're going to use stages as a drum machine. So I've got some white noise, a triangle VCO, and a low sine from an oscillating filter. I've got 3 square wave LFOs and 3 single green segments. So I'm going to patch this into the VCA that has the sine wave. We're going to use that as a decay envelope. We're going to use the first square wave LFO as a clock. So this will change the decay length. And this will change the speed. Next, we're going to do the same for the other 2. And we're going to patch those the same way so that they're all clocked from square wave LFOs. We've got the snare. And we've got a little metallic percussion. But they're all totally unsynced. So how do we get them in sync? Well, we use the clock divider function of stages. So we're going to mult this into the gate. And we're going to mult the same one to the gate. And now this LFO is acting as the master clock, and these 2 are acting as clock dividers.